I'm coming to you from a block height of 922,072. I'm going to do a quick overview of mining, halving, and the difficulty adjustment. Simple definition: Bitcoin mining is the process of verifying transactions on the Bitcoin blockchain by solving mathematical puzzles for which miners are rewarded with new Bitcoin. This right here is the halving cycle equation, which we will jump into later. If you buy a $2 lottery ticket every 10 minutes, you'd spend $100 in about 8 hours. That's 50 tickets in one day. So if your budget was $100, it'd be spent in one day. If you buy a $100 Bitcoin miner, it enters the Bitcoin hash lottery every 10 minutes automatically, and it keeps guessing billions of times per second forever. Mining blocks. So we'll start out with this little equation here. I put it together to kind of simplify it. The network creates a hash string of characters for the block awaiting transactions with a difficulty set based on network activity. This includes the history, all the timestamp, basically the longest chain of viable data is what the network always clings to and what all nodes and all miners reference from. So that network hash is your data from the blockchain, and you're adding X, which is your input as a miner. You can change that, and that is all. That result, after it is scrambled with SHA-256, has to be less than the difficulty target, which is set by the network, and we'll be jumping into that. So, Bitcoin miners start generating hashes, the X inputs. The goal is to generate the target hash, one that's less than or equal to the difficulty target. The first miner to generate the target hash gets to attach the block to their copy of the Bitcoin blockchain, leading zeros. Basically what that means is the less than means the number physically just has to be smaller. But it's not as easy as your miner going, okay, I'll just spit out a small number. SHA-256 is what it goes through, and it spits out a randomly generated string. So you can't, it's not that simple. Security nodes check that the hash is correct. If so, the block is added to the official ledger, the longest ledger, so all nodes and all miners will then reference from that one. The Bitcoin miner then receives block rewards. Blocks offer a set amount of Bitcoin as a reward. The amount is cut in half every 210,000 blocks that are mined. This system is called proof of work. I'm sure all of you have heard that, because miners need to prove they expended computing power during the mining process. Basically, trial and error, trial and error, trial and error. They send that data, or they do this when they provide the target hash to the network. So, there you go. Mining in like real terms as most people know it, and in our terms. Those are all the transactions waiting. This is a simple bitaxe hashing away, trying to win that block. SHA-256 produces a 256-bit hash. This means there are exactly 2 to the 256 power possible unique outputs. I'm not reading that because I've never read it out loud and I'm not about to butcher it on a recording, but it's a number so large it dwarfs the number of atoms in the observable universe. And here's that number there. It is 78 digits. And miners try an infinite range of inputs. So that X value can be anything. All I'm saying here, this large number is the possible number of outputs for SHA-256. So it's infinite, the inputs. They use the network uses double SHA-256. That's a pretty cool fact. Searching for a hash below a target value, enough leading zeros as mentioned. The hash space, yet again, but the target space is much smaller, like aiming for a needle in a haystack. You're throwing darts, hashes, at a dartboard with 2 to the 256 spots. The target is a tiny bullseye somewhere on that board you cannot see. You keep throwing, hashing, until one lands inside the bullseye. The only way you win is you try again and again. There are no shortcuts. It is one chip that ultimately solves the block, so you have a chance at home over those large farms. That's why you can't cheat at Bitcoin. So let's say everybody's working on block 91. That's the whole network. Multiple miners are trying to get that thing on the chain and keep it moving. But one miner wants to alter transaction number 74. He'd have to make his changes and redo all of the computations for the blocks 74 through 90 and do block 91. That's 18 blocks of expensive computing. Basically, it is impossible unless you have a source of infinite energy, and even then the network is so large at this point to where you could not beat everyone. You have to do it all before everybody else in the network finished just one block, because it goes off of the longest chain. So he alters this, and if that one's done, a new chain basically spawns, and he's stuck in basically a branch timeline that doesn't exist and is not verified by the network, so it's all for nothing. But that's where I think it's the game theory part of Bitcoin, where the incentive is, it is more viable if you had the computational power to hurt the network or take it over. It would be more useful of your time to mine and get those rewards. So it's pretty cool how it's all been set up from all angles, because we expect foul play. Now we're going to get into the halving cycle. Genesis, the reward was 50, then it halved. On the first halving, halving 1, 25 to 12.5, 6.25. You get it, right? Each cycle is triggered at 210,000 blocks, approximately every 4 years. There's a 21 million fixed supply of coins. So, infinity over 21 million. All the value in the world over 21 million. A new concept, absolute scarcity. We'll see how humanity handles it. I hope we don't flop it like we flopped money to begin with. This equation here, let's talk about that. This E actually is sigma. It's a Greek letter. Means we're just going to add a bunch of things. These are the things we're going to add. How many times are we going to add it? I equals 0 is where it starts. That I right here, we start at 0. We go all the way up to 32. Plugging it into this equation here, and then we add all of that up. That will result you in 21 million. So the point of this is, as you plug in for I, your variable, you're going to get these outputs. Those outputs are the total mined in that cycle. Notice how each cycle it's halving. Also, the reward is halving. Pretty cool, right? So if you want to take just this part of the equation right here, and you want to find out the block reward, you just plug in for I, for whichever halving it is. Best way I remember these numbers, because it starts at 0, it's confusing for some, but just imagine 1 is your first halving. 0 means Genesis. So yeah, plug in for here, and then you'll get this result every single time as you try it. Here's the year. Go ahead and pause, look this over, screenshot it. I really, really like this one. This is the best part of it. Look. Circulating supply percentage. First halving, 50% already out. And then 75. And then 87. And then boom, by the time everyone started understanding that this even existed, over 90% of the supply was already out there. And then as we approach the year 2140, then we'll reach 100. But the block reward just gets nano. So that's why when people say that your sats are going to be worth quite a bit in the future, because they truly will. Like 2025, at the time I'm recording this, current block reward is 3.125. That's $300,000. That's life-changing money for someone. And I imagine that trend will probably continue as it raises in value and time goes on. So something cool to think about. And then right here where my cursor is where we're at. We're early. That's what people mean when they say that. Early, but kind of not really. See, we're right here. This is the digital gold rush. We're approaching the end. I'd say it ends at about, I don't know, honestly, 98, 99. Bitcoin issuance schedule. Green is the supply, how much is getting inserted in, and the inflation rate is the reward, and how that's halving. So look how beautiful that relationship is. Once again, a great image to pause, screenshot, share, whatever. The difficulty adjustment. Every 2016 blocks, the network audits how fast they've been mined and adjusts for it. The target allows this interval to be every 2 weeks, 10-minute average block time. If blocks are mined too quickly, difficulty increases. If blocks are mined too slowly, difficulty decreases. Difficulty can only adjust by a factor of 4 in either direction per period. The new target equals old target multiplied by actual time over expected time. If actual over expected is greater than 4, then the new target equals the old target multiplied by 4. If actual over expected is less than a quarter, then new equals old multiplied by a quarter. It's like a shock absorber for the network. Smooths out hash rate spikes or crashes, prevents manipulation by large miners, and it keeps Bitcoin's heartbeat steady. So here's a visual, kind of what's happening. Really kind of a smart way of adjusting itself. It can't adjust too far in either direction because that allows for manipulation. So let's say a huge farm or multiple farms get in cahoots and shut down all at once, basically to trick the network to lower its difficulty, and then they all spike on at one moment. You see how that's an issue? So that's kind of what this whole difficulty adjustment is for. And that's why as you see the hash rate spike, people mention, oh, it's much harder to land a block. This is why, because more people are trying. Block reward equals the percent of the total supply. If you divide the total mined in cycle, this, of any given halving by 21 million, it results in the percent of the total supply mined for that cycle. That percentage is also equal to the block reward of any given cycle. A really cool, profound thing. Shout out 88 Sats Jor. He posted something that made me add this. Here's an example. 10 million, 500,000 over 21 million equals 0.5 or 50%. You see, that number is 50% of the total supply. And that works for every single halving that you plug in the total mine-in cycle. So just reminding you, 2024 halving, that's where we're at. And in roughly 2028, we're going to split off to 1.56. But by then, that's going to be a lot of money. Or, sats. Bitcoin halving cycles. Deflationary by design. 50, 25. And we just keep on declining. So yeah, right here, as I said, this is the digital gold rush. Just like when people were setting up those camps in the hills of Idaho, till all the gold was gone from the hills, and then they all dipped. See, this is kind of where we're at when it comes to gold. People are still finding it. It's just a little harder because people went nuts. But this is by design and actually scarce. But I like this graphic here because block reward, C, on your Y. Also on your Y is the percent of total supply mined. It correlates. So it's cool. Total number of Bitcoin created by miners. Over 95% of the Bitcoin has already been mined. So here's another chart. Basically it's this one, but in a different font. Yeah, I highly encourage you just pause, take screen caps of these visuals, and then dang, that's probably enough value as is. I'd like to end with this. Bitcoin is everything people don't know about computers, combined with everything they don't understand about money.